Hey HMS Modelers, this is Mike Bartles from the Hydrologic Engineering Center. This video is a recording of a presentation that I made to a group of U.S. water managers and hydraulic engineers that focuses on recent forecasting enhancements within HEC-HMS. However, most of the features that are discussed are applicable to all applications of HEC-HMS. Enjoy!
I'm a hydraulic engineer at HEC. I have been the team lead for HEC SSP for a couple of years now. This year, I took over the team lead role of HEC-HMS. So I've been an HEC-HMS team lead or a team member for 5 years now, ever since I got to HEC. But before that, I worked in the Philly district. So there, did a bunch of modeling, did a bunch of forecasting, this and that, dam safety stuff. So experience with HMS runs pretty deep. I still like to communicate with everybody and see how everybody's using it. So I would like this to be an interactive presentation as much as possible. I'm going to be spending a lot of time in the actual software. So I won't PowerPoint you to death. If you do have questions, please bring them up. Looks like the microphones are muted, but I guess you can raise your hands, so on and so forth. Either way, I like to have a back and forth discussion with people. Hopefully I'll show you some new things. Maybe you guys have seen these already, but I got a couple of tricks and tips that you guys can use to make your SWIMS models faster and also display a whole bunch of new and cool information to make informed decisions. We had a pretty massive storm roll through here, or still, for the past couple of days and the weekend. It looks like it's going to happen. So HEC is actually without power right now. So if you guys have been trying to access the HEC share, that's down. All of our DevNet stuff is down. So I'm happy that I made this backup PowerPoint. Because I was just planning on doing this live and just showing you guys our website and how all that stuff works. Now we can't actually get to that website right now. So here we go. All right, so within this presentation, I'm going to give a little bit of background on HMS, all the things. So we've done way more than just updating the software recently. I want to talk about that a bit and how that can help you. Talk about the documentation that we have to go along with the actual software. And then I'm going to demo a bunch of new things that have either come out within the past year, maybe a little, we've started the groundwork for a couple of these things before that, but and show how they work within the current existing framework. And then at the end, we'll talk about some upcoming enhancements, things that we're excited about, and take time for questions as well. All right, so the latest release is version 4.7.1. 4.7 came out in December, I believe it was, early December. Had a ton of new features like 2D flow, discretizations, all sorts of other things. We made a bug fix release in the beginning of January, so please grab that one. And that is especially pertinent for SWIMS and WAT users because we had some bugs we needed to fix specifically related to the save as and import features. So please go and grab this from our website when it's up and running again. Grab the portable version too. It doesn't require ACID input to install. If you get the primary, the regular release here, you will need admin rights. Don't need admin rights for the portable version. We also have a beta version of 4.8. So when we make releases, we try and push out the next beta because we're constantly developing new things. We want you guys to test them. That does work within the Cavi. It does work within WAT as well. So if you want to try that one out, you can. If you're a Mac or Linux user, there's also download packages available for that as well. I am not, so we'll leave that one at that. Documentation is all online now. Gone are the days where we're trying to just push out static PDFs. And the reason that we did that is because if we make a release today, find a typo in the documentation tomorrow, we'd like to get that to you as fast as humanly possible. So we include links in the software to all this documentation. I can make a change to that and push that to our server, and that updates instantly for everybody to see. So all this stuff is done that way. Our quick start guide, user's manual, applications guide, tech reference manual, the release notes, a validation guide. And the big thing that we've been working on a whole lot lately is tutorials and guides. So if you've read the tech reference manual before or the user's manual or things like that, they're heavy. They're very big. They're tomes of material. The tutorials and guides are meant to be much more easily digestible pieces of information. If you want to see how to build a model from scratch and you want to be able to get through that in, say, 15 minutes, here's a tutorial and guide for you to do that. I included a link to that page over here when everything is back up and running again and we have power at HEC. Go and check that out. This list is huge and it's only getting bigger. We have people that are actively contributing to that as well, district and division personnel. So if you're interested in writing a tutorial and guide, short and sweet, these things take us like a day, 2 days at most to write. Let me know. Contact me, reach out. If you think something is missing in here, something that would be beneficial, please let me know. I'll probably turn around and ask you to write it because you know what is best to go into that section. So definitely take a look at these. All the stuff that I'm going to talk about in here, all the stuff that I'm going to demo, there is a tutorial and guide for each and every one of those individual subjects. Go look at them. They're very, very valuable. We updated them very recently. We are in the process of updating the tech reference manual. I have chapters done for losses, base flow, transform, channel routing, and snowmelt. We're just looking to update that on the actual website. The user's manual is constantly being updated. All this stuff is live. All this stuff is being updated as we speak. So please, can't say that enough. Go check those out. All right, now for the demo. I'm going to jump into the actual software and talk with you guys. While this is going on, that's a quick snippet of things we can do with an HMS now. We visualize SWE over time, but I'll show you guys how to actually do that. First, I'm going to jump in and use HMS 4.7.1, but I will go to version 4.8 beta to show you some of the cool new features after we're all done in here. So the watershed that I'm going to work with, I'm glad I chose this one. I did this actually last week. This is for the Truckee River. Does everybody know where Lake Tahoe is? Hopefully you do. This is Lake Tahoe in here. Reno, Sparks is over here. The town of Truckee is right here. This just got a ton of snow. There was like 24 inches of snow or whatever that fell over the past 2 days at some of the NRCS snowtel sites. So a lot of stuff is going on here right now. I should have a webcam. I'll show you guys in a minute while that's going, what the actual conditions look like right here right now. As it rains on us, it snows on them. So this is a pretty typical SWIMS HMS model, right? You get it, and you upgrade it to version 4.7.1. Nothing is geo-referenced. You have a couple of shape files in the background. Typical processes that you're using in here, deficit and constant losses, Mod-Clark unihydrograph transform. This one I use linear reservoir base flow. I've built a lot of models using recession base flow in the past. It's good for a quick stab. Linear reservoir is what I would recommend people to use. It conserves mass. It's a lot more straightforward. It doesn't need very many modifications once you get it calibrated. Anyways, I've built this one to use linear reservoir base flow. The discretization now replaces grid regions. So gone are grid regions, and that's a good thing from a programming perspective. Also a user standpoint. Grid regions were really hard to work with in the past. But the grid region itself, in this case, is a file specified one where we're just using a .mod file that was created from HEC-HMS. Right? I can't even tell you how many emails I've gotten from people saying, I can't make this file, it doesn't work for me, ArcGIS gives me this super cryptic error. I have no idea what those Esri errors mean. They are nonsensical. I can try and troubleshoot your model with you or your ArcGIS project with you and try and figure out what's going on, but you don't need to generate these files anymore. If you do want to generate that file, you can actually do it within HMS now, so you don't need to use HEC-HMS. We are 95% of the way there. And by 95% of the way there, I mean 95% of the way you don't need to use HEC-HMS for 95% of the use cases out there. There's a very, very small, slim use case that I can see where people might still need to do a couple of things in ArcHydro, HEC-HMS, but those are very, very few and far between. And I'll show you some of the cool new things in 4.8 that'll make those go away. So first thing that I want to do is georeference these features, right? They're not polygons. They're just points, right? The subbasin elements, they're just points in space. Let's get rid of that, and I want to georeference those existing elements here, so I'm going to click on the GIS georeference existing elements option, and now that brings up a wizard where you can select either subbasins or reaches. Let's start with subbasins. I'm going to click next, and now I'm going to actually go to where this file sits, and this is a shape file that I'm going to use to georeference them, and that's HMS subbasins shape. So I'm going to select that file, then I go to next, and in this step in the wizard, I need to select the attribute that contains the names, right? So it's trying to key off of what is the shape file and what is the layer or the feature in the shapefile, and what is the subbasin element itself. So these got to match, right? If I have a feature in that shapefile that's Lake Tahoe space S10 and not underscore S10, they don't match. You won't georeference that feature. So if I click finish, now they're all georeferenced in place. I'm going to go ahead and get rid of that shapefile. The key is to get rid of all shapefiles. Don't do shapefiles in here anymore because they take longer to draw. Look how much faster we can draw those than other shapefiles. Hopefully you guys have done this to your models. If you haven't, this is a must-do. Please do this. Go and georeference your features. Dump all the shapefiles that you guys do have within your models, unless there's a very specific reason that you do have them in there, because most things you can represent with HMS elements. I can also do that for routing reaches, right? So look how these guys are straight. Sometimes I like to look at them like that. Sometimes I don't. I'm going to go ahead and get rid of the stream center lines layer 2. So now I don't have any shapefiles, and I'm going to georeference my reaches. And I'm going to select my HMS reaches shapefile. And again, same thing applies. I need to have an attribute within that shapefile that corresponds to the name of the actual reach. If they don't match, they will not be georeferenced. So I'll click finish. Notice that those all came in just fine. Now my reaches are no longer just straight shots from one point to another, the beginning and end. Now they actually have vertices along the way. I can click on them, so on and so forth. If you don't want to visualize it that way, you can still turn off reaches, and they'll be visualized as straight lines. So you can leave them on like that. Either way, this stuff is a lot easier for us to draw and render in HMS. So it makes things load faster. That's key. So if you guys want to save time, please georeference your features. It allows you to click anywhere in the polygon too to select that, right? I don't need to click right on that element there. Garrett, you asked a question real quick. It looks like you were asking if I developed them in 4.7.1. I did not. These ones were actually the shapefiles that I used. So I built this model maybe like 2 years ago in GeoHMS. They were the shapefiles that actually came out of GeoHMS. If you do the delineation process in HMS, there's no need to do this georeferencing thing. If you start from scratch with a trained model, you go the whole way through, everything will be georeferenced from the get-go. No need to update that. But you can. I'll show some tricks and tips for doing that later on. So now everything is georeferenced and in place. I can compute through and look at a whole bunch of different things if I wanted to, but let me do one more step. I can actually use terrain data in here, not just for visualization, but I can also use it for additional processing stuff. So I'm going to actually import the NED 30-meter data set that's been clipped to this modeling domain. Let's say GIS, DEMs, NED 30 meters clip. Nobody should ever be working in meters. I got to change that one to feet. All right, now that I actually have a terrain data set in here, if I select my basin model, now I have an entry within my terrain data dropdown. I'm going to select that guy. Since this is already georeferenced, right, I georeference those features. I don't need to select a projection or coordinate system for this basin model, but everything all aligns in space where it needs to be. Now I can see where everything is, so on and so forth, but I actually have some additional stuff that I can do on top of that because I have this terrain model in here now. Like I mentioned before, all the elements are using a file-specified discretization. It's just using the .mod file, right? So there's a list of cells, their travel length, and their area within the actual subbasin. I can compute, that's just fine. I can visualize results even if I wanted to do that, but I would rather use a structured discretization because that gives me better representation of where things are in space. When we're using .mod files here, we don't really know where they are in space. We just know that within the subbasin, there is this list of cells. They are this big, and there's this much length in between the cell and the outlet. I can do a better job of that if I change this from file-specified discretization to structured discretization. So I just use the global editor here, or the override here. So if I go parameters, discretization, change method, I can change it for every single element. Or if you have a few selected, it'll just be for the selected elements. But now I've changed every single one of them, and they're all going to use the SHG projection and 2,000 meter cell size. And the results are all going to be written to this SQLite file as well. So that's where we put all of our geospatial information. When you actually do stuff in HMS, it's all going to go into an SQLite file. If you're doing something other like 2D flow, it'll go into an HDF file, but just in general, that's where that's all going to go. So now that I have that in place, if I want to actually compute the grid cells for this guy, all I got to do is pre-process sinks. So again, like I did in previous demos before, this fills in all the sinks, making a hydrologically corrected DEM. And if I do pre-process drainage, this will do the flow direction and flow accumulation processes, right? So if you remember from working in GeoHMS, this could take hours sometimes, depending upon the size of the data and also how flat, super flat areas are, like the lake surface itself or Lake Tahoe. It might take a little bit longer to do that than if you didn't have a lake in place, but this should only take a few seconds in HMS. So while that's going, let me actually pull up the webcam for what it looks like right now up at Donner Pass. So here's Interstate 80 moving through. This is Donner Lake right here. This is Lake Tahoe. Look at how much snow is on the ground there right now. Definitely don't want to drive through there right now. Lots of snow. Road conditions are treacherous, so to say. All right, that's finished. Now I have a couple of additional map layers. Let me go through them and talk about each individual one. As you saw before, this was the hydrologically corrected DEM that was generated from the sync process. These are all the locations that were actually filled in. Turn that off. The flow direction grid was created from that. If you zoom in, it looks pretty sweet. You got one of your 8 directions. They're all listed in place. And your flow accumulation raster, where you can actually visualize the dendritic network. These are where all the streams actually exist, or where the DEM suggests that they would exist. So this is an accumulation of cells, right? So if I hover over that, now that I have the flow accumulation raster selected, and I hover over it, I get listings in the tooltips. That is how many cells actually drain there. Where there's one, that is the only cell that drains there, that's a divide. But if I go downhill and I get to an actual stream, 37,664 cells drain to this location. So that can be used to actually identify streams. You go on through, you can actually delineate your watersheds that way. We'll do that in another step. But now that I actually have this DEM processed, I can do GIS, compute grid cells. And it'll go through each one of my subbasins, see what discretization option it's using, it's structured discretization, I mean, whether it's SHG or UTM projection and the cell size that goes along with that. And this computes not only the cells, overlays them, clips them around each individual subbasin, but it also computes the travel length that goes there too. So if you ever have problems using GeoHMS, you know, obviously I'd ask you to raise your hands, but I can't see everybody's camera at this point. Everybody's hands should go up at this point. This was difficult to do in GeoHMS. You kind of had to say nice things to the computer to make this work sometimes. This should be a whole lot easier to use in HMS now. Our attempt at doing this, or intent at doing this, was to take a lot of the hassle away from the GeoHMS usage. So hopefully everybody can see that. Now we have grid cells overlaying every subbasin at 2,000 meter resolution, right? We saw how fast that went, how quickly that was done. Hopefully everybody's super pumped up about that. If you can, give me a couple of emojis in the WebEx, because we can do that. All right, so don't need to use the mod file anymore. Use structured discretization. If for some reason you still didn't want to compute a mod file like you did in the past, you can use this create grid cell file option here. But you don't need to do that with structured discretizations. This is all that's needed to be done. Also, now that I have the terrain all processed and in place, I can do even cooler stuff, like compute subbasin characteristics. Right, so I'm going to click on subbasin characteristics here, and this is going to bring up an editor that allows me to visualize, or at least tabulate, all the longest flow path lengths, the slopes, centroidal longest flow path, or centroidal flow path, their slopes, 1085, blah, 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 so on and so forth, all through here. This was the most memory-intensive process computing longest flow path length in GeoHMS, because it was a 32-bit process, and it needed to load every single terrain grid into memory and actually process them all in one fell swoop. That way, you could actually run into some memory problems and have GeoHMS fail or ArcGIS fail from that. Notice how fast that went. Again, we're trying to cut time out. Like, this should make things a whole lot easier for people to process in here. Now that you have this information, what is this actually useful for? Well, if I go into Parameters, Transform, Mod Clark, now I have this new option down here for Calculator. Once I click on that, this brings up an expression calculator that should look pretty similar to things that you've used in the past, similar like raster calculator and ArcGIS. But I can actually use equations and some of these characteristics to compute some of these parameters, right? So simple ones might be 2 times longest flow path length. If that for some reason was a regionally derived regression equation for time of concentration in your area, you could use that and say calculate. Or it could be really complicated where you use longest flow path length times centroidal flow path length. And then I might want to do the product of that divided by, say, the square root, I'm going to change that to that, of the 1085 flow path slope. Let me go ahead and move that around. So that syntax right here will do 2.2 times the product of longest flow path length times centroidal longest flow or centroidal flow path divided by the square root of the 1085 flow path slope. I can nest functions in here. I can do all sorts of interesting and fun things in place here. There is a tutorial and guide, like I said before, for everything that you're seeing today. There is a tutorial and guide for using this. In the future, we'll probably include some sample equations in place and have a little bit better syntax for you to see what errors actually exist in here. But you can use that. I won't calculate anything in here because I calibrated these parameters and wanted to stay put, but you can see how that would go. Those are also available from, say, loss, deficit, and constant calculator here. And I'm going to stay on the grid tab because, say I created a grid from GSurgo, right? I got soil texture for the entire Truckee River watershed. And from that soil texture, I used, say, Rawls, Bracken, Seek, and Miller's published values of this is a decent place to start for saturated hydraulic conductivity. So every single small polygon that's denoted as like, this is silty loam, this is clay loam over here, this is sand over here, whatever. I have a saturated hydraulic conductivity to go along with that. Well, I can use that to estimate my constant rate because I can load that in as a grid. And then I can just say, yeah, select me that grid, and then when I hit calculate, it'll do zonal statistics over each one of these subbasins overlaying that grid, right? So it's going to take every single polygon or every single feature that resides within that area and do some calculations on that to give you an average over that subbasin. Every single one of these grids, if you go to Components, Grid Data Manager, every single one of these grids that you can load in here right now can be used in that way. So if you have a roughness grid, go ahead and choose that. Maybe you can't use preset frequency, then check that one out. It might be another one you can't use within there. But anyways, there's a lot of different choices of grids that you can use in this place and use for your processing. You can estimate parameters in HMS now. Again, another thing you don't need to do in ArcGIS. Super powerful thing. I'm very much excited about that. All right, so now that I have all this stuff in place, my parameters are good to go. I don't need to modify that. I might want to compute and see what the results look like. So everything computes as I would expect. I can visualize flow, at a specific location or an element, right? So I'll click on the Reno element here for the specific time period. Great, I can see the hydrograph, but I kind of want to know what SWE looks like. Well, if I go to results, I can check that simulation run, and for this subbasin here, which is, I think, Reno or Truckee River S40, I can look at snow water equivalent and see how that looks. Great, that's a basin average, but I really want to see what the distribution of SWE looks like. Well, if I go to compute, simulation run, click on that simulation run, now I have a new option in here to visualize the spatial results. If I turn that on and say yes, I do have options for writing out the results at greater intervals in my simulation interval, but I am computing at a 1 hour time step. Let's just leave it at 1 hour. Now when I recompute, those results are going to be written to an output HDF file. And this drop-down menu is now going to be populated with the spatial results that were computed for that simulation. I'm using precipitation or distributed precipitation. I am using temperature index snowmelt, so there's additional variables in there. If I were using 2D flow, there'd be an additional ones for like hydraulic depth, water surface elevation, velocity, so on and so forth. but I can go all the way down to see SWE here. So let me check that. Need to process some animation tiles. That'll take a second, but this allows me to animate these results over time and see how that goes. Now that they've been processed, I can visualize the accumulation of SWE throughout time. Maybe I don't like the way that that looks. If I click on the cogwheel here, I can change the values that are actually going to be displayed. Maybe I want to go in between 0 and 10 inches, and I don't want to use that default depth one. I want to use the sequential blue color ramp. The linear scale is all good, so it's going to go from 0 to 10 inches down here. This would be 5 inches because we're maximizing, or maximum value is 10 inches that I specified here. So I apply and close, and now I can visualize the accumulation of SWE over time. Right? So notice that SWE accumulates and melts over this time period in a couple different sequences. Now we're in the rain shadow on this side of the mountains over here. And you can see how that ramps up and down on this side. You can click play and let it roll through. If you want to, you can stop that, and you can actually use your mouse to drag and drop it, or drag it where you want, or you can use your keyboard to step through each individual time, right? I have other variables that I can look at, like, say, cumulative precipitation. That'll use a different default ramp and scale. So this is used in the National Weather Service colors. It goes between 0 and 50, I think it was 0 and 50, whatever else over on this side. I did see a question come through if you wanted to look at ATI. Yes, you can visualize melt rate ATI if you wanted to. I think the scale on that one, that's just, yeah, whatever, 10 is okay. And the default ramp for that is sequential yellow, orange, red. So if you want to look at that differently, you certainly can. Let's look and see what that looks like. So you can see how the melt rate changes throughout time. So low values all the way up to high values, especially on this eastern side of the drainage divide here, and down on the eastern side of the mountains there on Mount Rose. You see that there's a pretty heavy melt rate that's building up, or melt rate ATI that's building up there, but that is computed every single grid cell. So we've always been computing these values per grid cell. We just didn't have a really good way of visualizing that. Now you can visualize that with an HMS. So we have plans on further enhancing this. Obviously, we want to do additional variables, but we want to say, like, just give me the max. I want to see what the maximum is. Like, click a button and it just, regardless of time, show me the max that was actually computed. Minimum output to another format, output to a static grid, you know, hover over and see specific values if I wanted to, so on and so forth. This is just showing me elevations. Those are the tooltips that are shown right there. Play with this. I want to know what you guys think about it. I'm super excited about it. I want to know, you know, what you guys like to visualize. Things that I do with an HMS pretty consistently is I look at SWE, and I can load in static representations of snow-covered area, right? So I might go into the SnowDash grids, process them for a specific time, and say, what is the actual snow-covered area? So give me a contour at 0 SWE, and I can compare that against here. So I can load in a shapefile, say add, load that shapefile of snow-covered area, go to the specific step, and see if that corresponds to what I'm looking at here. And I can do that live in here. And I can actually go and then change parameters, right? So I would go back, let me collapse that down, select that net model, go to snowmelt, and I can actually go to my global parameter editors, make my changes for snowmelt. Maybe I need to raise PX temperature to better match that snow-covered area contour that I'm specifically interested in. But I'm using spatial results pretty heavily to actually see the distribution of parameters. This list of spatial results will change depending upon the processes that you do use, right? So if you weren't actually doing any losses, that would change things. If you were, again, I'm using temperature index, so I have a whole bunch of additional parameters within here, so on and so forth. Yeah, so give that one a shot. Let me know how that goes. And again, there's a tutorial and guide that goes along with that, so you can see how that goes. All right, did I get all the questions? I don't know, Andy, you see anything else before I go on to using some of the new version 4.8 features? I'm going to stop.
Yeah, I think you had one other one. Jeff Jaquez asked if we'd be able to see the visualizations in the CAVI at some point.
That I don't know. I'm not sure what the plans are for CAVI visualization. We can see though.
Hey, Mike,
the other folks.
Sorry to interrupt you.
No, go ahead.
I believe the best bet for people is
yes,
to just run HMS from within the CAVI for now.
Streams and build walls in version 4.8.
I think we've got
in a couple
some ideas,
especially
here on the dashboard.
Yeah, before you go on there, just if you can maybe talk about a couple of things. If folks, as they, update their SWIMS models in the future, every so many years, they might want to redelineate, maybe split a couple of subbasins, maybe aggregate a couple. How many minutes would that take with this process? Do they have to copy a basin model and do it? How much time would it take, or do you recommend they start a brand new basin model? Similarly, if they have another related question, if they get better DEMs a few years later, is it as fast as what you showed there to get all the characteristics and build a brand new basin model with all the parameters they care for?
Let's do it. So I was planning on leaving 15 minutes for questions. Let me see if I can get through it in 10 minutes. The next step that I was going to do was delineate additional subbasins within this Little Truckee River S30 watershed. In particular, this is upstream of Stampede Dam. This is a Bureau Reclamation Dam here. There's a tributary that comes in, I think on this side, HN Creek, and there's another one, Independence Lake, or Independence Creek that comes in here. There are two gauges. They're pretty small. One's like 7.5 square miles. Another one has 10 square miles or something like that draining to it. But if I wanted to make a delineation there, let's go ahead and do that. So at this point, because I wanted to show Paul as well how you can do build walls and burn streams, I'm going to leave version 4.7.1. You can do this in 4.7.1, but we don't have build walls and burn streams yet. Let me just show you how that feature works. I'm going to go ahead and open this up in version 4.8. Go away. So I'm going to convert that project from 4.7.1 to 4.8. Pretty much everything will look the same. Major new thing though, now I have terrain reconditioning in place here. So I'm going to make a copy of this because I always want to be able to come back to something in case I do screw it up, which I inevitably do most of the times. But I'm going to call this one, say, update. Now this is just a straight copy of everything that was in place before. And I also don't want to do anything in here because when I redelineate elements, we have to delete everything that's in place. So let me just make a brand new basin model. Don't care what it's going to be called because I'll delete it after the fact anyways. Now that I have this basin model in place, just select NED 30 meter. This is now saying, hey, do you don't have a coordinate system for your basin model? What do you want to do? You have to have a coordinate system for your basin model. Do you want to import from the DEM, which is georeferenced, or do you want to select one yourself? I just want to import from the DEM. So I'll select skip. Now that I have the DEM in place, now I'm just going to roll through all these processes, right? So I can do build walls and burn streams now. I'm going to select for my walls, HMS subbasins. Smooth rays will just do one buffer or one cell around that 100 feet and 1,000 feet for the smooth and sharp rays. You can play with that. You'll get different results, possibly. Now for the streams, I want to make sure that this stream centerline that I have goes through all of my walls. You don't want to leave any of those features in place or else the fill process will give you some weird results. Again, I'll do a smooth drop buffer of 1 cell and a height of 10 and a sharp drop of 10 or 5 and 10. Once I finish, we'll see that goes through. I'll show you the differences between the two. This is going to force my delineations to be exactly along those lines. I can make sub-delineations within there, but a typical process that I might use is like burn in 6 polygons or something like that. And then within there, I might want to delineate subbasins at 50 square miles or something. Once it finishes, I'll show you what the differences are between the two DEMs, and you'll be able to see the results of the build and burn process. Oh, I did see another question come through from Russ. When's version 4.8 going to be released? A month or so, maybe a little bit more than that. We're still trying to put additional couple of things in there and fix some bugs. Use the beta now and give us a couple of weeks to address any bugs that do come up. Please report what you do find. It would be great to have more people trying this thing out. So you can pretty quickly see here's all the walls that were in place. Let me just turn off terrain. This is the base terrain. This is the reconditioned terrain. You can see that there was an actual stream cut through Stampede Lake. These are all where the walls all go. We're trying to make things simple. So if you do terrain reconditioning and there is a reconditioned terrain available, when I do pre-process sinks, it will use that reconditioned terrain. If you didn't do terrain reconditioning, it's an optional step, it won't use that terrain. So I'm going to go through the same process that we did before, where I filled in my sinks. This is where all those sinks are actually filled in. And I'm going to do my flow direction and flow accumulation steps as well. And then I can actually delineate subbasins. All I want to do is do better delineations upstream of Stampede Lake because I lumped it all together into a single 150 square mile subbasin. Maybe I want to have better stuff. And while I'm thinking about it, there is a tutorial guide to do this exact process right here. So go and check that one out when we get power back at HEC, of course. We'll let that one finish.
Hey, Mike, while that's running, we do have a couple other questions that were coming in right before you started this.
Great. What we got?
Somebody asked if there's a way to visualize snow dash grids to aid with calibration, or if it's best to generate contours and load a shape file.
Yeah, we're getting pretty quickly to, we need to rethink the way that we actually interact with spatial variables and shape files and layers and things like that. Currently, no, you cannot visualize those grids within the map layer or within the map panel here. We would like to do that in the future. We're thinking about it, but right now you can't do that. If you have a shape file, like I talked about, of say your SCA, your snow-covered area, so delineate a contour at 0, there is everything on that side is snow, everything on that side is not snow, is bare ground. You can compare that way. You can also look at, like, here are contours of 0, 5, 10, 15, 20 inches. Compare against it that way. But right now you can't do that. All right, let me keep rolling. I'm going to see if I can get this done in 5 minutes. I'm going to do the GIS identify stream step. This will give you a default value. I'm going to replace it with, say, 25 square miles. And now I have streams at 25 square miles. That's great. I want to add a single breakpoint. Oh, before I do that, I want to make sure that I align with what I had from before. Let me load in my HMS shapefiles. So this is subbasin boundaries. And again, I had one subbasin upstream of Stampede Dam. I'm going to place a single breakpoint there, call it outlet. Now, I don't want to visualize that anymore because I don't particularly care about it. I'm going to go in GIS, delineate elements. Just put in stuff here because I like my subbasins to be S underscore something, R underscore something to start with. And I could click delineate. This will only delineate elements upstream of that single breakpoint. I can have a whole bunch of different breakpoints in here. I might have put a breakpoint for the gauge at Independence Lake and one at Sage-Hen, but I'll do that in another step to make it a little bit simpler. It gave me 3 subbasins. That's cool. Next, I actually want to go back and say delineate me elements at those gauges. So I'm going to load in the gauges themselves. Here's the gauge for the lake. Here's the gauge for Sage-Hen Creek. I want delineations there. I don't have streams going through there, though. Well, I can run GIS identify streams again to give me a new stream threshold without affecting these delineations that are already in place. So I'm going to say, yeah, I want to do a new delineation, and I'm going to use 5 square miles instead of the 25 that I had before. Now I actually have streams that pass through those areas, and I can split this element, right? So say I'm going to select that subbasin, say GIS, split element. Let me zoom in to where this gauge is actually located. I'm going to click on it. It has to be on that stream alignment. Now it's going to say, hey, I found all these subbasins in here. Do you want me to actually delineate them? Yes, I do. So I'll go ahead and I'll do that there. And I also want to delineate for Sage-Hen Creek right there. I'm going to say GIS split element. right there at that gauge location. That looks great. I like that. Now, let me just get rid of the elements that I don't want. So I'm going to merge those guys together. They can be one, GIS merge elements. Those ones can be one, two, GIS merge. There's two streams right here, reaches. I don't want those to be separate ones. I'm going to merge those elements. I also don't need anything up here, so I'm going to GIS merge. Or I do want that to be represented. I just want multiple subbasins in GIS merge. And now, this is a layout that I can use. I can go through and rename them real quick if I wanted to. Like this one should be Little Truckee S30, Little Truckee S40, Little Truckee S50. Same with the routing reaches, just using the naming convention that I typically go with. But I don't particularly care in this case. And just for quickness sake, we'll just let that go for what they are. Now I'm going to do GIS export layers. I'm going to leave it as subbasins because I want to output all these subbasins. I'm going to click next. And I'm going to say, hey, I want these to go in here. I'm going to call this, I'm going to put underscore, so I want it up front, updated subbasins, shape. Now those are output. I'm going to do GIS export layers again, and I want to do the reaches. I want to do updated reaches, shape. Do finish. If I go back to my winter update, again, I updated this guy, right? I don't want that one to be here anymore. Let me just turn off discretization so I have less to look at. I'm going to select that guy, click OK, delete that one. Now I have it here, and I can go GIS, import georeferenced elements. I want to do subbasins, and I want to use the updated subbasin shapefile. Click next. There is an attribute of name in there already, and now when I import them, did I not import them? Oh, they did. I'll have to check on that one. Those subbasins are in place. I can do GIS. Let me just do shutdown and restart. This is still a beta. I got that. SDK Truckee. Winter update. Now that I have those in place, I can do the reaches as well. GIS, import georeference elements, reaches, next. Updated reaches shape, next. Yep. And now they're in place as well. So now I have all my elements. None of them are connected, mind you. So I would need to do, connect downstream. I'd like to put junctions in place. So, I might have this junction here is called Independence Lake. And this one is Stagehand Creek. And this one is Stagehand Creek Confluence and Independent Creek Confluence. And then I have all my elements connected to those junctions, but, so it goes. You can do however you would like to do it. And you can easily parameterize again. So now I have all these elements in place. Let me go ahead and do GIS or parameters, characteristics, subbasins. Now all these new subbasins that I have in here, now all their characteristics are in place. And I can compute time of concentration using regression equations. Or I can use, TIFF files that are in the background for constant loss rate or maximum deficit that I computed for Sergo to estimate my loss rate parameters. And I can do the same thing for reaches, right? Because I have reach characteristics that I can compute here, so I can use some function of length or whatever else to initially estimate, and velocity to initially estimate travel time through the reach. So Muskingum K, and just set X to 0.25 or something like that. See, I can do that. So that was 10 minutes that I set that up. Obviously, it's not all complete, but give me another 5 minutes and I can have a run going there. But wanted to leave time for quickly to talk about some upcoming features and then handle questions as well. So if there's other things that people want to see, I'm totally willing to demo that at another time, but I want to be cognizant of everybody's time. Everybody's working hard, so leave enough time for that. Let me skip back over here. Please check out the slides. I know I gave these to Andy. He'll post them somewhere. You can take a look. I have links to all of the tutorials and guides for each one of these steps. You can check them out if you do have input. Let me know on some of those ones. Some upcoming enhancements. So, current slide. Like we talked about, we have build walls and burn streams. Version 4.8 is on our website right now, the beta. Please grab it, try it. Let me know how it goes for you if you have any questions, how things work, want to work on us or work with us on documentation. That would be great. Unregulated outputs, that's another one. So that is actually in place. Let me show you that real quick. So I have an example for East Coast. Go file NAB West Branch Susquehanna. And I have a single basin model, summer forecast. I have 2 forecast variants that were created within the CAVI, so I just compute them in place here. One is for no future precip, and the other one is for, with QPF future precip. Now that we actually have unregulated outputs in place, notice that there are messages that are coming up on the compute dialog letting you know it's actually being computed. So we'll let you know when the MET model is being computed, when the basin model is being computed, and when unregulated outputs are being computed. So this is a basin model setting like you used to do or you're used to for local flow or replacing missing data, selecting terrain data. Now there is another one for unregulated outputs here. So if you have this turned on, there'll be a second roll through all of your compute to compute all of your reservoir and diversion elements as if they were set to none. So it's just straight pass through, right? That results in things like this. So if I go to, what's a good one? Beach Creek Station. Nah, let me go something bigger. Like Williamsport. Great. So Williamsport is right here. That's where the Little League World Series takes place. There are 4 reservoirs that are upstream of Williamsport. I can go and see outflow and observed flow. And I'm used to looking at that. Observed is in black, computed is in blue, but I can also look at unregulated data. So I can plot that now, and the unregulated outputs are in dashed blue. So I can see that the difference between computed and with reservoirs and without reservoirs is pretty massive here. So everybody congratulate the Baltimore District on their managing of these projects. They reduced the peak flow rate at Williamsport by 25,000 CFS, something like that. That's great. You can check all those differences on downstream. So it essentially rolls through the computes twice and computes them all as if the reservoirs were set to none, the diversions were set to none. So very, very quick way to do that. Let's go back to here. We will visualize characteristics like longest flow path length. So you saw them in the table. We can actually visualize them within the map. I was going to use a build that actually had that, but I couldn't get to our servers, actually grab that. So they are there. We will be able to show them in version 4.8. We can compute 2D sediment. So we could use 2D flow, the same 2D flow algorithm that Raz was using. We can use the exact same one in HMS. We can actually compute 2D sediment transport within HMS as well. Faster computes, we're always trying to make things faster for everybody. So compute times, especially for 2D, have been halved like 4 times now since we initially started working on that last year. Controlling output, by that I mean specifically reduce the amount of output. So if you literally don't want anything to be written out, there's a minimum number of things that we have to write out. But if you want to save time on hitting disk for writing output, you can do that. That's really, really flip for doing uncertainty computes. I don't need to write out things that I'm not going to use, especially if I'm doing 100,000 simulations. So scale that back. And also better jobs for working with relative path names and missing DSS files. That specifically comes up from time to time in the forecasting community. And another thing that I want to mention, so we're going to be doing quarterly webinars as well. Since we have so many new features that are coming out, we want to start doing this for everybody. We're going to kick off the first webinar. There will be a meeting invite sent out. I got to work with Chris on that one. But February 18th, 11 a.m. Pacific, we'll do our first one. We're going to try and increase awareness of new features and materials within HMS. And we're going to do that by focusing on a couple of features per webinar, talk about it, demo it, have people ask questions, and so on and so forth. So we have like 4 of them already planned. We'll keep doing these in perpetuity as long as there's interest in it. So definitely partake. So conclusion, I know we talked about a whole lot here. I went pretty quick through all these, and I'm going to leave some time for questions. Latest release is 4.7.1. Definitely use that right now because we made enhancements and bug fixes for swims. Please use that. Next release is 4.8. The beta is on our website. Give that a shot. They both work within the CAVI. So place them in your package, and they're good to go. Tons of new features. We're constantly making improvements, not just bug fixes. And more things are on their way. Please check out our documentation. We work on them a lot, and we want that to be better and serve you guys. So I saw some more questions come through. Andy, you want to hit me up with some of the questions?
Yeah, there was a couple from earlier I want to make sure we hit before we get to the ones at the end. There was a question about early on about the user manuals. It says that there's no option to download the entire user's manual, only chapters. Is this because you were always updating the manual?
Yes and no. The plugin that we have right now to actually do PDF conversions leaves a little bit to be desired. We like things to be live. We want you to get the latest and greatest information. And we also track. So another thing that we do is we get statistics on who's visiting what page. If a lot of people are visiting the page on spatial results, then we know that people are using that feature. And we know that we need to spend more time increasing documentation, usability, so on and so forth. We're trying to roll this up to make a better product for everybody. So static PDFs don't really help us too much in that regard, but we do recognize that people still want them, so we're working on that.
Okay, so there's another one. When we were talking about visualizing data from Simeon Benson, he said, does rain show up here? And I think, Simeon, if you want to unmute and ask that question again, just to make sure we understand what you were wanting to ask.
Yeah, sorry, that was big, and I might have just missed it, but I was curious if, if we can use these other parameters, if we could get, gridded rainfall showing up here too.
Yeah, like
I know that already does that.
Like Avatal had asked for visualizing observed SWE. We can't do that right now. Obviously, you can use it in HMS. We just don't have a means to do that. There might be something simple that we can do in the meantime. If that is something that you guys really, really, really want to see is observed precip. Well, let me look at that. There might be something that we could do pretty quick. But currently, that is not an option. It's just computed results.
Yes, I know MetView already does it, so, y'all decide what y'all think is best. But I find it very helpful when calibrating, especially in real time, to see where the rainfall actually happened. So I often use MetView at the same time.
I should note that this, let me select that run. While this is computed, so to say, this is at the resolution of the actual spatial result or the discretization that you have specified in here. This is the observed precip. It's just been applied to the actual HMS model. So you can visualize those results. I guess I should have restated that. This is incremental precip. This is from the MRMS product, multi-resolution, multi-satellite, I think it is, source, multi-source. You can see how precipitation is distributed throughout here. Does that answer your question?
Yeah, that's perfect.
Okay, very cool.
Great. So the last couple questions that came in, one was from Paul Simon about computation time changes between 4.5, 4.7, and then 4.8, and I think you hit on that briefly on your slide.
Yeah, in terms of quantification, we did have a table that we were trying to keep live from version 4.3 to 4.4. Like for a model like the West Branch Susquehanna, the speeds were improved by like 50%. You tacked on snowmelt on top of that, and we made additional improvements. Tommy worked on reading paired data in a more informative way, cut down on the amount of hits that we made to disk, so that improved speeds there. 4.5 was faster than 4.4, 4.6 was faster than 4.5, 4.7 was faster than 4.6, so you get where we're going. We're never making things slower. If you find that to be the case, let us know, and we would love to use your project as a benchmark. We are computing, we have like 3,000 tests that we run, regression tests, every single time we build HMS, and we benchmark their speeds as well. So not only are we comparing, like, we used to compute this value, we compute this value, are they the same? If they're not, we need to figure out why they're different. But we also compare it used to be this fast, now it's this fast. Is this faster now than it was in the past? If not, we need to figure out why. So benchmarking a lot of things.
Great. And then the last two I think are related, so I'll just read them both. What method is used to calculate unregulated flows, and can HMS compute holdouts?
All right, so unregulated flows are computed, if I go to Foster Joseph Say or STAM, as if we set this to none. This thing turns into a junction. So computed inflow is passed through the reservoir with no attenuation or translation processes from the actual reservoir itself. So it's almost as if the reservoir isn't there at all. That is unregulated flow on downstream. We've already gotten some comments about that. This is fast and simple to do that, and I believe this is in line with how 95% of other people compute unregulated flow, but we're not computing holdouts and then routing the holdouts. And the reason why is because we use nonlinear routing processes with HMS, right? So 50,000 CFS through this reach goes a whole lot faster than 5,000 CFS. 50,000 may be the unregulated flow and 5,000 may be the holdout. You would get very different results if you routed 50,000 from here to here versus 5,000 from here to here. You could. There's some processes that are purely linear, like Muskingum, that doesn't do anything different for the magnitude of the actual flood, but Muskingum Kunj does. Modified pools does. So we want to give you the best representation of unregulated flow that we can. I don't know. Any other comments, questions about that one?
My guess is what Russ is wondering about is relative to using just HMS fed to a RAS model for computing FIA damages, if that HMS could be snipped out of that workflow if the reservoirs are simple enough to operate them in HMS.
Do you need the holdouts or do you need the unregulated flow? Because if you need the holdouts, you can do some math in place, right? What's the difference between these two? So what's the difference between unregulated and this? You just do a subtraction of the time series. That's all of them. You don't have the option to individually turn ones off. RESIM is a scalpel in this case. HMS is a hatchet, right? But you can swing a hatchet pretty quick. So if you have improvements for this, please work with you. We'll make it happen.
All right, last call for questions.
So Mike, 4.7 has the ability to start working with like changing parameters and doing the math yourselves and doing, and then 4.8 is when you can start to burn in streams?
Yes. Yeah. 4.7.1. Please use 4.7.1. But yes, you're right. The only reason I hit that is we made specific enhancements and bug fixes for swims and WAD. I would hate to screw you guys over with a bug in 4.7.
We got another question about, can terrains built in HMS be used in RAS and vice versa?
Yes. Yeah. You can import a terrain from RAS into HMS. You can import a terrain from HMS into RAS. These are actually written out. So in this case, right, I have a process terrain file. If I go to the actual guide itself, if I go to GIS, winter update, here's where all those terrains are actually written. Those are TIFF files. And the reprocessed, I should say, reconditioned, is that guy. So if you wanted to import that, you could use that. You could use any one of these. Definitely would like to be cool like the RAS team, make multi-resolution terrains and things like that, and pyramid things a whole lot cleaner than we do, but baby steps. We'll get there. Any other questions? Did I get everything?
I believe that's all that came through the chat.
Awesome. Well, if you guys do have other questions, hit me up on email. I'll do my best to answer you as quickly as I can. When Discourse is back up and running too, definitely let us know if you have any comments or questions. Bugs that you encounter, please try version 4.8. We count on you guys, especially the forecasting community, to let us know if there are any issues when it comes to version 4.8 use within CAVI. So it'd be great. Appreciate it.